Welcome, Lesson 3.2, Linear Plots. Let's go ahead and read this. In this lesson, you will learn that the starting value and the rule of a recursive sequence take on special meaning in certain real-world situations. When you add or subtract the same number each time in a recursive routine, consecutive terms change by a constant amount. Using your calculator, you will see how to do the starting value and the rule that you generate data for a table quickly. You will also plot data sets and learn that the starting value and rule relate to the characteristics of the graph. So let's do this example. You walk into an elevator in the basement of a building. Its control panel displays 0 for the floor number. As you go up, the numbers increase by 1 on the display, and the elevator rises 13 feet for each floor. The table shows the floor number and their heights above ground level. So here's the floor, here's the height. These numbers should look really familiar to you. So what we're going to do for part A, write recursive routines for the two number sequences in the table. Enter both routine into calculator lists. Then we're going to define variables and plot the data into table for the first few floors of the building. Does it make sense to connect the points in the graph? Good question. And lastly, what is the height of the floor with less than 200 feet? What is the highest floor with a height of less than 200 feet? Is there a floor that's exactly 200 feet high? So let's go ahead and try and do just this first one. So what we have to do is first let's write recursive routines for two number sequences in the table. So what we're going to do is first is let's go ahead and look at the floor number. Well, what's happening with the floors? We go from 0 to 1, 1 to 2, 3, 2 to 3, 3 to 4. They're all going up by 1s. So the floor number starts at 0 and goes up by 1. Okay, so that's for the floor number. Alright, and now let's look at the height. And we start at -4, right, 4 feet below the ground. And then we go up by 13. So now, if you remember from the video that we did before, what I had to do is I actually went by hand, and then I said plus 13, plus 13, plus 13, and I said, actually, it's a little bit faster if you just keep on hitting enter. But then I had to keep track of how many that was, so I had to say it out loud. This was the, I don't remember which floors they were, but this was like the 10th floor, 11th floor, 12th floor. And I had to try and keep track of that. If I have to do this a whole bunch of times, it's really easy for me to forget what number I'm on. So what we're going to do is, let's use the calculator to help us write both of these routines into a list, okay? So what I'm going to do is I'm going to clear this out. Ooh, I don't want to clear all of it out. Let's just go down to the bottom and let's see if we can do that. And what I would like you to do is to write some of the steps down. That way when you get to the graphing calculator in class, when I see you, that way we don't have to go over all this again. You can just kind of have some ideas of what to do, all right? So what we're going to do is we're going to hit second bracket, second parentheses to get this bracket, okay? And now I'm going to do floor number first. So our floor number was 0, and then I'm going to do a comma, and then what was the height at this floor number? Well, I think it was -4. So then we're going to type in a -4, and we are going to close our bracket. All right. If you remember, we actually did this once before. We did this with when we were doing the number tricks. You could check a whole bunch of different numbers at one time. So now what we're going to do is something a little bit different, okay? Because now I want to be able to do two different things. I want to do something to the floor number and something else to the actual floor height. So what I'm going to do is I'm going to hit second bracket. I'm going to open up these braces again. And then I'm going to say second negative, which is answer. And I want to do answer parentheses 1. And I want to add 1 to the floor height. Or I'm sorry, to the floor number, right? So the floor number is 0. Take this first answer, add 1 to it. Good. So then we're going to go comma. And now I want to do answer 2. So second parentheses 2. So I'm going to take my second number in my list. And what are we doing with that? Well, if you remember, we're going up by 13 feet, right? So I want to be able to take this second one, and I'm going to add 13. And then if I close my brace, let's see if this is right. I have 1, 9. That corresponds to 1, 9. Oh, hey, that's really good. And if I hit enter again, I get 2, 22. Hey, that matches up, so that means I probably typed in everything right. So again, bracket, floor number, floor height, answer 1 plus whatever we're doing, answer 2 plus the adding of the 13 feet. Okay, so there is my recursive routine, and I entered both routines into calculator lists. That way I can go through and I can keep on doing this. right? So I can keep going. I can get the 5th floor is 61 feet up. All right, so there's part A. Now let's do part B. Define variables and plot the data in a table for the first few floors of the building. Does it make sense to connect the points in the graph? Okay, so the height, the feet, depends on what floor we're on. So this is going to be my X, and this is going to be my Y. So we're going to have X's go between 1 through 5, and my 5th height was 61, so probably go up by like 10s or so. So I have, this is my floors, right? Floor number. And this is height. Alright, so you see I've got my floor numbers here, and I have my heights over here. I went up by 10s. And notice how I put my 0 here. I have negative 10 here because my first floor is actually negative 4. So I'm going to go ahead and plot these right now. And there they are. So now what we should do is let's make sure we look at this. We've got floor number, we've got height, and then, oops, the question that we have was define the variables, plot the first few floors. We did. Does it make sense to connect these points? So should I connect them? They look like they're very linear. But if I graph this point, I'm talking about some floor height that's between, or floor number that's between 0 and 1. So we're talking like the half floor. I don't know what that means, and I don't know what that looks like, so I don't think that makes sense at all to plot that point, because that means we'd have all these points in between. We only have first floor, second floor, third floor, and so on, so I don't want to plot anything in between them. So it does not make sense to connect them. Alright, and let's look at number 6. What is the highest floor with a height of less than 200? Is there a floor that has exactly 200 feet high? So what we're going to do is let's go back and let's look at the calculator, because that's probably the easiest one. So we're looking for 200. So if I just keep going up, what's nice is that I still have all of this in my calculator. So there's 100 feet, 113, and now I'm on the 11th floor. Here's the 12th floor. Here's the 13th floor, 14th floor, 15th floor. If I go to the 16th floor, I've gone too far, so 204. So the highest, the floor number that's closest to 200 without going over would be the 15th floor. And is there one that's 200? Nope, 16 is the closest with 204. So what is the highest floor of a height less than 200? That is the 15th. Whoa! Should we just use that one? I don't think so. Let's go back and make that smaller. I was hoping we could just keep it, but my handwriting's not that great. So we have the 15th floor is, that's an O, not 15th flower, 15th floor, that's better. And then is there a floor that's exactly 200 feet high? That answer is no. Alright, so there you go. Good luck, and remember, if you need to go back and kind of watch this again for what we need to do for the calculator to get this far, that's alright, because then you'll have the notes for this, and then we can get right into it when we go through the example for class. Alright, good luck.